In match problem 3, now we have a manufacturer selling sunglasses with a current sales price of $21. So this is our value for P, our current price point. And we're given a price demand equation, which again is solved for X. P is the independent variable. The current price is increased. Will revenue increase or decrease? So there's nothing in this question that says anything about calculating elasticity, but anytime we want to talk about what effect price will have on revenue, we want to keep in mind we're always coming back to this idea of elasticity. So the first thing we want to do is establish that elasticity function, which in this case will be negative P times the derivative of 9,500 minus 250P all over 9,500 minus 250P. So the derivative of this will just be minus 250. And then we can divide each of these by 250 to get our final function here, P over 38 minus P. So we know that our current price point is $21. So we want to evaluate E of 21, which in this case will be 21 over 38 minus 21, or approximately 1.24. So in this case, we can identify demand as being elastic. So if price is increased, which is what the question is asking us, that will lead to a decrease in revenue. With, again, the idea being that as we increase the price, we're losing customers, and we're losing too many. We're losing too many that additional cost per item that we're bringing in isn't making up for the number of people who have stopped buying our product. So even though the question isn't asking for it, we can provide the correct interpretation or the correct advice. So to boost revenue, we should decrease our price. So charging less will bring in more customers who want to buy our product and will more than compensate for that decrease in price per item. So in the long run, we'll actually end up making more money. And then what this question doesn't ask us to do, but is a good skill to make sure you know how, is how do we find that ideal price? How do we find the ideal selling point? So in order to do that, we just take our elasticity function, set it equal to 1, and then solve for the price. So in this case, we have P over 38 minus P, which will set equal to 1. Multiplying both sides by 38 minus P gives us P equals 38 minus P. Adding P to both sides, we get 2P equals 38, or our price equals 19. So our optimal price point is $19 per pair. So again, anytime we want to find that optimal price, anytime we want unit demand, take the elasticity function, set it equal to 1, and then solve for P.